So now what I want to be able to do is not just control one LED with my Arduino, but add a second LED so that I can control actually as many rows of LEDs as I want to control. So we're going to start with just doing two LEDs, and we're going to hook them up such that the red pin, blue pin, green pin, so the color pins will be controlled using one Arduino input-output, digital input-output, with pulse width modulation on the colors. And then the rows will be controlled by their own digital I/O pins for on the Arduino. So I have now two LEDs, and I've got them situated with, common pin is the long one, and short one just by itself is red, and then green and blue. So I'm going to split these so that the common and the red are by one another and the green and the blue are by one another, and just go ahead and set this into my breadboard here. And I'll do the same thing with the second LED. So before, when we just had one LED, we hooked the LED directly up to the through the resistor to its respective color pins that we were going to control with the Arduino. But now, because I have more than one LED, I'm going to create a sort of row that I can use to drive my color. So for the green, actually let's start with blue. So blue we're going to control with the number 11 pin. So I'm going to put that into 11, and I'm going to make the blue supply be this negative supply on my breadboard. So this, if we recall from our breadboarding, this entire column is connected like it's in one single wire. And same thing for this column. And same thing on that other side here. So I'm going to use these columns to be my supplies for my colors for the Arduino. So I will connect my blue LED pin from the first LED to the blue row, or the blue column. And I'll do the same thing for the second LED, connecting its blue pin to my blue supply column, or my blue driver column. I want to make sure that the wires are not touching this resistor. I just have not cut down yet to size, but it's a good idea to do that. I can do the same thing with the green. Green I'll drive with pin number 10, and I'm going to bring this over to the plus column over there. So this is sitting on this plus column right here, so that now I can drive all green parts of the LED, or green LEDs, from this plus column. And then I connect that through my resistor to the LED. And finally, I'll do the same thing for red, except that my red wires I cut a little too short, so I'm going to just jump it over using a part of the breadboard that's not being used. And I'm going to make over here on the other side of my breadboard the red plus column, my red driver. So I'll hook that to the red pin on my LED, on both LEDs through the resistor. Alright, so we've got one part of our circuit now done, and we need to now have somewhere for the current to flow. So we'll use the other another set of digital I/O pins that will control which LED gets lit up by letting current flow through either one of those or both at the same time. So I'm going to choose 0 to control this LED. So I'll connect through pin 0 up to this common pin of this top LED and do the same thing. I'll choose pin 1 to connect, control this second LED. Connect to its common pin. Okay, there you can see my circuit. Now I have power able to go through each of the colors to my LED, through that LED, and then back to the Arduino, so that I can basically control both LEDs, so I can differentiate and turn one on and off and turn the other on and off and control any of their colors. So let's now see what the code looks like to be able to do that. So now we've got our circuit all hooked up the way we want it so that we can control more than one LED and its color, but we need to change the code that we've been using in a little bit in several ways. So the way that we want to change the code is to allow for us to have more than one LED. We've been sort of just worrying about one LED's common pin, and now we can write arrays and functions to turn on and off the LEDs, the two that we have in our circuit, turn them on and off independently. So to start to do that, I want to create another constant, and I'm going to call this in rows. And right now we just have 2 rows, but we essentially could have many more than that, as many pins as we have available almost for our digital pins. So here I'm just defining the number of LEDs. And for now it's just 2, but we could have more. I'm going to keep red, green, and blue, meaning 0, 1, and 2, just as before, and my red pin, green pin, and blue pin are 9, 10, 11, respectively. Now I have here an array of my color pins, so I want to do an array, which is just a list that the computer can sort through or step through, really, is what we want to do. So I'm going to create a constant and integer list or array, and I'm going to call it row pin. And to define how many things are going to be in my array, I use the square brackets, and then I want in rows of row pins in my array. And now I tell it what those members of the array are by using curly brackets, and I'm going to say in my array I have 0 and 1. And those are the members of my row pin array because I hooked up the common pins of my LEDs to the digital I/O pins 0 and 1 of my Arduino. So that's a list of the Arduino I/O pins that I've hooked up my common pins to. Now I can delete this LED pin because we've defined it as an array now. So here I'm just okay. So now I have several of these functions that I defined so that I can turn color on, and I can choose its intensity, and I can turn it off, and then I can turn all colors on or off at one time. I no longer need this custom color bit of code, so I'll delete that for now. But what I do need to do is have some code to be able to turn an LED on and turn it off, and then turn all of the LEDs on and all of them off at the same time. So I'm going to start by defining a function. I'm going to call it LED on, and it needs to know what row of LED I want to turn on. So that's the argument that I'll pass to it. And inside that, we know that we turn on an LED by setting its pin mode. And we want to choose from my array, my list of row pins, and I want to tell it which row I want to choose. So I'll use that argument that I passed to my function row to tell it which one, and then I'm going to set that as an output. So if I wanted to turn row 0 on, I would type the command LED and in parentheses 0, and that would, or LED on and then in parentheses 0, and that would tell my computer that I want to turn row 0 on. Same thing, I want to do an LED off, and I'll pass it a row argument, and as before, oops, to turn the LED off, we'll set it as an input. So now I have a function to turn one LED on and one LED off. I'm going to use those to be able to turn all LEDs on and all LEDs off. So I'm going to define another function to do that. All LEDs on, and I'm not going to need to pass it any arguments, so I put void in the parentheses, open a curly brace to define what goes into my function. So I want to be able to turn all of my LEDs on, and when I have a repetitive command, this is a real good time to use a for loop. So I'm going to use for, and I'll just iterate on integer I from when it's equal to 0 to I less than n rows. Get some spaces there so it's a little more readable. And I want to, every time the loop runs, I'm going to add 1 to I. So in my for loop, I will call LED on of I. So each time it runs, it's going to, each time this all LEDs on function runs, it's going to call LED on, and which row does it turn on? It's going to turn on the ith row, so starting from 0 to I less than n rows, and n rows we've defined up above. So it'll just iterate through all of the rows that we have and turn all of the LEDs on. We want to do the same thing for turning them off. And again, we don't need to send it any arguments, so we'll give it a void incoming argument. We don't expect anything back from it, so that's why we have the void out here in the front. So again, we're going to iterate through all of the LEDs. And I'm just going to use the argument I, the variable I. And I'm going to use the same procedure as I do with turning them all on, except my command that will happen is I'll use the function LED off. So that will go through and turn all of my LEDs off. So now I have done all of the functions that written all the functions that I need to turn one LED on or off at a time, or all LEDs on and off. Now I need to change my setup to be a little bit more efficient. Instead of initializing all of the colors one by one, I could actually replace that with a for loop. And same thing when I initialize my LED pins, the row pins, I want to do that in a for loop so that I don't have to do quite so much typing. So I'm going to change this to a for loop, and I'm going to say for, oops, I'll iterate on color from color equal to 0 to color less than n in colors, which I defined up above to be 3 because it's red, green, and blue. I'll add color, add 1 to color every time I iterate through the loop. And each time I do this, I want to set the pin mode of that color pin, and I can use my array to decide which color pin I want to be talking to. So when I want to initialize it, I want to initialize it as an output, so that this pin is expecting to give information out, not expecting to get information in, so it's an output. So we'll initialize all of the color pins as an output, and then I want to make sure that they're all off, which means I'll set their intensity to 0. So this is using the function that we created before of color on, which is just the function that I defined above to set the intensity of the color. So it's going to say color on, this color pin that I'm telling it to use, I'll set its intensity to 0, which is basically turning it off. So now I have my color pins initialized as outputs, and they all should be off. So now I need to do an initialization for my row pins. So the row pins, we want to, instead of turning them high or low to turn them off, we'll set them as low so that we connect it to ground so that current can flow through our LED, but we want to set its mode as an input so that we don't drive current backwards accidentally through the LED. So we did this in 2 statements, here and here, before, but now that we have more than one LED, we want to do this a little bit more efficiently. So we'll use a for loop again. So I'll say for, and I'll say integer row, so that I know what I'm iterating on, from row equals 0 to row less than n rows. Oops. And because I want to keep my comments here, I'll just close this curly brace down here. So I'll set the state for the LED pin low, and I do this using a digital write statement. And I'll just look into my array row pin that I already created and tell it which element of that array to choose by sending it the argument of row. And I'll, whoops, I made a comma there. And I'll set its state to low. And then we want to initialize these row pins as inputs so that we don't accidentally drive the current backwards until we're ready to drive it forwards and have the circuit run. So we'll set its pin mode. Whoops, I can't spell digital. So digital write. Arduino's nice, the programming environment that it turns things that it recognizes or functions that it recognizes colors so that you can know that you've written that correctly. So pin mode of row pin, and I'll tell it which element of the row pin array to choose by sending it the argument row, and I'll set that as an input. Okay, so I should have now a function that will initialize all of my row pins, set their value to low, and initialize them as an input. So that's the part of setup that I have to do. What I'd like to do is to make sure that I have some code to show when I'm running setup and to show that I can control all of my colors. So I'm going to select all of this fade in, fade out stuff that we programmed before and copy that. Actually, I'm going to cut it and put it up here instead of in loop where it would repeat over and over again. I just want to put it in setup so it runs one time. So now I'll have that color fade in, fade out pattern happen in setup one time to show me that I can do all of the turning on and off of colors that I want to do. Okay, so now in loop, what I want to do is be able to turn my colors on and off separately, or turn my LEDs on and off separately. But one thing I want to make sure that I have done up here is turn all LEDs off before I move on to the loop function. Oh, and actually before I do all of this pretty color turning on and off, I need to make sure that all my LEDs are on so that I can have all of them show. Oops. And I'm just using these functions that I created previously, and just so that I can line everything up, make sure that I have everything. It helps me see that I have everything with the right amount of open and closed curly braces for my functions and my for loops. I use the tools and auto format, and it just moves things to line up nicely. So it looks like everything's okay so far in setup. So I'll move on to my loop function. And in loop, I'm going to blink back and forth between the two LEDs so that I can change them back and forth. So what I'm going to do is turn one of them on and then off, and then turn the other one on and off so that I can blink back and forth. And to do that, I can say LED on, and which one LED I want to turn on. I'll decide I'll start with 0, and I'm going to have it blink red. So I'll set its color to red and its intensity to 255. I want it all red. And I'll delay, say 100 milliseconds, and then I'll turn the color off. And delay 100 milliseconds. And then I want to turn the LED off now that I'm done with it. And I'm going to do the same thing I don't need that anymore because I now have a function that will do that. I'm going to do the same thing with the LED connected to row pin 1. So I'll just copy this and change that to 1. So I'm turning on and off 1. And I think instead of red, I'll turn on and off blue. I want my other LED to be blue. Okay, so let's pause a second and we'll hook up the Arduino and see if our code works like we expect. We expect to show the color on and off, or the color fade in and fade out sequence that we programmed before, and then we expect to be able to see the two LEDs blinking red and blue. Now I have my Arduino connected to my computer, and I have the circuit set up like I showed before, and I'm ready to upload. I found one bug in my code. I'd forgotten to capitalize here the C in all colors off. So if you found that, good job. And the Arduino compiler told me that that was an issue when I tried to compile. So let's go ahead and save this, and we'll upload our code to the Arduino. Now you can see it go through the fade in, fade out sequence, and should go into a blink. So it kind of looks like red and blue flashing lights, which is exactly what we had planned. So what I'm going to do now is put these little balloons over the lights so that it's a little easier to see on camera. Now that you saw the circuit that was underneath there. There we go. So you can kind of see that a little bit better. Okay, so now I can play a little bit of a game with my delays. I can reduce the delay from 100 milliseconds to 10 milliseconds, and I can have it flash even faster. So let's see what happens when we do that. We'll upload the code and wait for it to go through its sequence of startup, and then we'll watch for it to see how it flashes. Now it's flashing pretty darn quickly. Almost looks like just a flicker. Now I could go even faster. I'm going to reduce this delay to 1 millisecond. And see what happens. And after my opening sequence, now I just looks like I now have just red and blue lights on, and that's all. But in fact, they're blinking so quickly that we can't distinguish the blinks. And so we're going to use this fact in our project, our display project, that the Arduino can blink LEDs faster than we can distinguish with our eye. So we can now display a picture of our own creation that has whatever color we want, and we can control the rows of our LEDs so that we can display pixels in a picture as we're spinning our project. So we'll explain more about that in subsequent videos, but now we can see how we can control LEDs separately as well as their colors.